Okay, so in this class, we're going to discuss again first order, first degree differential equation. And in this entire lecture series, what we are doing, we are trying to solve differential equation questions that has been asked in previous year papers of physics and mathematics, uh, mostly in NET examination, GATE examination, ZEST examination, TFR, etc. And what we are trying to do is to grasp how to solve the differential equation here primarily. And in this pursuit, I'm going to discuss one of the questions that was asked in NET examination of mathematics in December attempt of 2013. So the question is this. So this is the question that was asked in CSIR NET examination for mathematics students in, I think, December attempt 2013. Is that so? Yeah, December attempt 2013. Okay. So I'm giving you some minute so that you just see this particular problem, and we'll start doing it. Okay. So how to do this particular problem? Let us see. Okay. Okay, let y be a function defined from R to R satisfying the initial value problem. IBP means initial value problem. Y dash t is equal to 1 minus y square t, where t belongs to R and y is equal to 0. Then yt1 is equal to 1 for some t1 belongs to R, yt is greater than -1 for all t belongs to R, y is strictly increasing in R, and y is increasing in 0, 1 and decreasing in 1, infinity. So again, I've told you that in any of the examination that you'll be facing, like here it is a question in mathematics, but even in physics, if you're going to face any of these examination, differential equation wise problem would not be stiff. Only see, this differential equation is like standard 11 differential equation, standard 12 differential equation, right? The difficulty would lie in understanding what are the qualitative aspects of those the solution. So this is what has been asked, that how would the solution would behave. So expect these kind of questions only. Okay, so you can expect these kind of questions. Although what I've told you that do some basic revision of your standard 12 book, that is NCRT, or some advanced engineering mathematics book, so that you are able to solve these questions promptly, because these are very easy questions, and I hope these questions will be able to do very quickly in the examination. Okay, so this is why I told you. So let us try to do this question. And what is my goal with this question is to make you understand graphs, because again, the question is on increasing and decreasing. So at least we'll be able to revise our curve sketching part also from this particular problem itself. Okay, so let us first do the try to solve this particular differential equation. So I know that y dash t is given as this, so dy upon dt. So instead of this, I'll write this and I'll integrate it. And this will be like 1 upon 2 ln of 1 plus y upon 1 minus y, and this is like t plus some constant of integration. Is that clear? I think this is quite clear from the very here. It is given that y is 0 equal to 0, which implies that your c must be equal to 0, because at t equal to 0, if y is given to be 0, it implies if you write 0 here, it will be 0, 0. ln 1 is already 0, t is 0, so c will come out as 0. So this is something that I'm leaving it to you. Just replace t equal to 0. At t equal to 0, your y is 0. So if y is 0, then 1 upon 1, ln 1 is 0, so c is equal to 0. So overall, I know that my solution part would be reduced to writing this. It's 1 upon 2, ln of 1 plus y divided by 1 minus y is equal to simply t. And here you can do some kind of manipulations, and I'll write 1 plus y upon 1 minus y is equal to e to power 2t. And then I have to release this y from here. So what I would do, what I should do, I would do this 1 minus y plus 2y divided by 1 minus y. So I'll write 1 plus y as 1 minus y plus 2y. So what I will get, I will simply get it as e to power 2t minus 1 is equal to 2y upon 1 minus y. And you can extract this 1 from here, y from here. So if I want to extract this y from here, I thought that there would be an easy thing to do, but okay, कोई बात नहीं, जैसा भी है. So what I'll do, I'll try to extract the एक काम करो इसको, try to take a reverse of it. So I'll write 1 upon y upon this 1 upon e to power 2t minus 1. So at least these problems get resolved, and uh, this will be like 1 upon 2y, and this will be like minus 1 upon 2, 1 upon e to power 2t minus 1. Place it there, place it there. So I'm solving it here. I'm solving it here. So I'll get 1 upon 2y is equals to 1 upon 2 plus 1 upon e to power 2t minus 1. And just take these LCMs and all those stuff. I think this is very easy to do. Okay. So I think this will be like e to power 2t plus 1 divided by 2 e to power 2t minus 1. And then this will be like 1 upon 2 here, and 1 upon y is written here. So cancel 1 upon 2. So y, eventually we have landed up getting y. So y as a function of t is given by e to power 2t minus 1 divided by e to power 2t plus 1. And if I do certain manipulation also, this will be, if you take e to power t common from here. So I'm just writing it here. So if this is fine, but I'm just writing, if I take e to power t common from here, I'll get e to power t minus e to power minus t divided by e to power t is plus e to power minus t. So this is like sine hyperbolic t divided by cos hyperbolic t. And overall, if you have a deeper look to this, this is nothing but this tan hyperbolic t. Is that clear? Now this is your function, okay, on which the question has been asked. So let us try to concentrate on this particular function, which is y as a function of t, which is incidentally your tan hyperbolic t. You can write it as well as e to power 2t minus 1 upon e to power 2t plus 1. Whichever way you wish to wish to write, I'll write it. Okay. Now it says that the first option says that y t1 is equal to 1 for some t1 belongs to R. Okay. So it is saying that there would exist some t such that if you replace that t in the solution, 1 would come out. So let us see, is that the case or is that the scenario possible? So according to the question also, let us consider that there is some t1 such that y t1 is equal to 1. मान लेते हैं y t1 equal to 1. What does it mean? It means that yt1 would be equal to 1. It implies e की power 2t1 minus 1 upon e की power 2t1 plus 1 would be equal to 1. Is that clear? And it implies what? It implies e की power 2t1 minus 1 is equal to e की power 2t1 plus 1. Is that clear? I mean, a बोला था ना by t1. Okay. And if you are ending up to this part, now you see exponential function is a 1-1 function. Exponential function is a 1-1 function. It implies that if I'm writing that t1 is not equal to, sorry, if t1 is there, so e की power 2t1 would be anyway e की power 2t1 only. Like these two would be equal. These two would be equal. If these are equal, then it reduces to saying that e की power 2t1 plus 1, sorry, minus 1 would be, let's say this is your graph of e की power 2t, this is your e की power 2t minus 1, and this is your e की power 2t plus 1. Is that clear? Now it says that at one point, let us say that is t1, I'm not able to figure out, let's say this is your t1, है ना? मान लेते ये t1. How can it be possible that e की power 2t1 minus 1 is equals to e की power 2t1 plus 1? Obviously, I can cut this thing up, and then I will write that minus 1 is equal to 1 is an absurd solution. That also would do. But understand that e की power 2t is a 1-1 increasing function. This is how it is made. And e की power 2t minus 1 would be downwards, and e की power 2t would be a displacement of this particular graph upwards. Now, if I say that there exists a point t1 such that e की power 2t1 minus 1, which is here, and e की power 2t1 plus 1 is there, how can they be equal? They can never be equal. So there does not exist any such t1 belongs to R such that e की power 2, sorry, such that y of t1 is equal to 1. In fact, you can also figure out that yt, if I write it as e की power 2t plus 1 minus 2 divided by e की power 2t plus 1, it will give you 1 minus 2 upon e की power 2t plus 1. Okay. Now, if I and I know that this particular function, what is the domain of this particular function? The domain of this particular function is all real R, because see, this can never be 0. E की power 2t plus 1 can never be 0 because e की power 2t is always positive, and if 1 is added to it, it will always remain positive. And also, you know that exponential is defined for all t belongs to R. So the domain of this function, that is tan hyperbolic t given by e की power 2t minus 1 upon e की power 2t plus 1, or e की power t minus e की power minus t divided by e की power t plus e की power minus t, the domain would be t belongs to R only. So domain of definition for this function would anyway be all real R. So what I'll do, I will try to find the limiting values to it. So what will be t tends to infinity? So if t tends to infinity, this will go to 0. So yt would become 1. And if I take limit t tends to minus infinity, if I take t tends to minus infinity, this will become 0. So this is 1 minus, I'll write it for you. So it will be 1 minus 2, that is minus 1. So e की power y as a function of t, there would be no such t, it such that yt would be equal to 1, because only as t tends to infinity, only then the limiting case of y would be equal to 1. It is not exactly equal to. Is that clear to you? Are you getting my point? There would be no such t such that if you replace that t in the solution by t, you'll get 1, because 1 you will only obtain in the limiting case of function. That is, only if t tends to infinity, you will obtain 1. And infinity is not a point as such. Understand my point? Infinity is not a point as such. It is just signifying that you are, what would be the tendency of the function to move as you take the values as large as possible. Okay. So this is not as such a point. So you cannot say t equal to infinity by 1 hour. So there would be no such real value such that yt would be equal to 1. Rather, you can say that in the limiting case, yt would tend to 1. And in fact, in the limiting negative case, negative infinity case, yt tends to minus 1. I hope it is clear. Till this part, everything is clear. Is that clear or is that not clear till now?
Clear, sir.
Okay. Now, let us try to see. The question also has a few options. Acha, yt is greater than minus 1, we'll see to it, and yt is increasing and decreasing, we'll see. So first thing that one needs to see is that what is the monotonicity of the function, whether it is a monotonic function or not. That is, whether it is increasing or decreasing, or what sort of monotonicity it does have. So, for example, if I'm saying it is completely increasing, I'll say it is a monotonic function. If I'm saying it's completely decreasing, I'll again say it is a monotonic function. But if it is increasing and then decreasing, then it cannot be a monotonic function. So let us first find the derivative of it. So y dash t would be equals to what? Y dash t would be equals to simply 2 upon e की power 2t plus 1 का whole square, and then you will have this 2 again e की power 2t. Is that clear? So if you differentiate this particular function, this 1 would be 0, this derivative will be minus 1 upon e की power 2t plus 1 का whole square, and then e की power 2t का derivative is 2 into e की power 2t, 2 into 2 is 4, 4 into e की power 2t. So y dash t becomes this, so I'll write this will be positive. Is that clear? It implies for all t belongs to R, yt is an increasing function. Yt is an increasing function. Let us try to make a plot of it, but first also understand that how would it behave at origin? Y0 would be 0. That is something that you can see from here, that if I replace t equal to 0 here, so it will be 1 minus 1, 0. So y0 would be equal to 0. And yt is a strictly increasing function, rather you can say it is a strictly increasing function. Is that clear? So yt would anyway would be strictly increasing. So till now we have done two options. So first option is correct. Yt is increasing in R, that is also correct. And don't worry, in mathematics, in net examination, more than one options can be correct. So don't think that this cannot be the case. It is the case indeed. So till the time physics people are saved, save yourself, because once these kind of questions are going to come in your examination, then you'll have to think on each of these options. So people who have given IIT exam and everything, they know like these questions do come in at exam as well. That is more than one correct option, and most of the people suffer there only. So physics people, you are saved till now. I hope you remain saved as well in near future also. But that is what it is. So yt is an increasing function, strictly increasing function in R, and yt1, yt1, this will not be the case. Yt1 is equal to 1 for some t belongs to R. Option is wrong. Yt is greater than minus 1. Yes, indeed, that I'll show you. So answer should be B and C. So let us try to plot the graph, and then we'll understand how option B is correct. Okay, so I know that my y dash t is greater than 0. That implies my function is increasing. I know that there would be no such person in this entire class who would be interested in finding second derivative. I think second derivative would be too difficult thing to do. So let us just make a graph by having an idea about it. Okay, exam में कोई बिल्कुल accurate graph तो नहीं बनाना ना हमको. So we just need a graph which gives you a certain idea, and a certain idea of graph like curve sketching I've already given to you, and from there only we'll try to pick it up. So these are my axes, and I know that like this is what it is. I know that this is my 1, this is y equal to 1, and this is y equal to minus 1. Okay, and I know that my function is strictly increasing, and I know that as t tends to minus infinity, यहाँ होता है t tends to minus infinity, समझ लो? As t tends to minus infinity, और y is tending towards minus 1. ये रहा माइनस, दिख रहा है? यहाँ से ग्राफ चालू होगा. As t tends to infinity, ये होता है t tends to infinity, your y is tending towards 1, तो यहाँ पर होगा ग्राफ. ठीक है, as t tends to infinity, function is trying to approach y equal to 1, as and here it is at 0. So obviously the graph has to start from here, increasing, 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 and then it has to go this. So it has to be increasing at a decreasing rate only. Because if it is increasing at an increasing rate, then it will cut it. So it has to be increasing at a decreasing rate here. That I'm not finding it for you, because that will be too pathetic thing to find right now, because इतना सारा नहीं हो पाएगा. Because second derivative also, you understand, this is a already first derivative is this big thing. Second derivative thing, then again it will take time. So understand that in any case, if it is asymptotic to y equal to minus 1 as t tends to minus infinity, and if it is asymptotic to t tends to like y equal to 1 as t tends to infinity, obviously it has to be increasing at a decreasing rate only. Otherwise, how it is possible? If it is increasing at an increasing rate, it will cut by 2. And here it will be increasing at an increasing rate only. Is that clear or is that not clear? So here it should be increasing at an increasing rate. For that, you need to find your second derivative also, but I'm just making a rough plot. Okay. So it will start from here, and then it will go on increasing at a decreasing rate and making an asymptote to y equal to. Is that clear? So this is how your tan hyperbolic graph is plotted. And you can see that your function is always greater than -1. Now don't say that yt greater than -1 में t में y greater than 1 भी तो आ ही जाएगा. नहीं आएगा. Understand my point? What it says that yt is greater than -1. Yes, indeed. Because see, y will always lie between -1 and 1. If y lies between -1 and 1, one thing is certain that whatever value come between -1 and 1, this certainly has to be greater than -1. Okay. So most of the times, most often students say me that y अगर greater than 1 हो गया, क्यों होगा यार? Tan hyperbolic t है ना, so it will always lie between -1 and 1 only. If it lies between -1 and 1, so option number 2, that is B statement, is correct. That is yd is greater than -1. Yes, indeed, it's always greater than -1. In fact, you will find that yt always lies between -1 and 1. And if it lies between -1 and 1, obviously it is greater than -1. So option number B and C are both correct. So this is your problem where my idea was to show you the limiting values. My idea was to show graphical approach as well. I hope you've got this particular problem. Is that clear? Is that clear? कहाँ चले गए सारे सारे? Is that clear? Alpna
Yes,
clear?
sir.
Bharat clear? Saloni clear?
हाँ भैया.
Okay, so we'll meet tomorrow. I'm trying to anyway push you to early times because I have certain commitments after 9. So I'll try my level best to be at 8:20 from tomorrow. But somehow I was at 8:30 today. But I'll try. I know it is difficult for you, but somehow cooperate. And if you can do that, it would be very good for us. So we'll be free by 10 a.m. anyway. And for people who have just joined, like the MSc people, I'm insisting that try to solve this Green's function part. We've already done 6 lectures here. Dirac delta function, we've done around 6 to 7 lectures. At least do both of these topics so that when I'll be discussing PYQs or questions in general, you will be at least able to understand all these things. And these are very important concepts in examination also and otherwise also. So Green's function, you can expect each year there would be one question. On Dirac delta function, directly or indirectly, there would be question. So in case directly कोई तुमसे Dirac delta function ही पूछेगा, then perturbation theory, Dirac delta potential, electromagnetic theory, there are several ways of asking this particular thing. So it's better you do both of these topics. So soon, while I'll be free from this thing, an ordinary differential equation, right now I'm going to do this way only. I'm going to teach you through problems only because I feel that at least you will be able to see how the questions are coming in the examination and work accordingly. And for that, I've already told you that do one book, at least one book, NCRT Standard 12. I think that will give you an insight to how to solve these first order differential equation. And BSc text, any textbook or any advanced engineering mathematics textbook would do. Okay. So I hope to meet you tomorrow. Till then, take care.